Dear student, let us study the chapter Interference and Diffraction of light. We first study the interference. This interference phenomenon is based on the superposition principle of waves. This superposition principle states that when two or more waves traveling through a medium arrive at a point simultaneously, then each wave produces its own displacement at that point independent of the other. Hence, the resultant displacement at that point is the vector sum of displacements due to all waves. That is, vector y is equal to vector y1 plus vector y2 plus dot 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 etc., where y1 is the displacement of first wave, y2 is the displacement of second wave, and so on, and vector y is the resultant displacement. Now, interference. Interference is the phenomenon in which redistribution of energy or modification in intensity of light takes place on account of superposition principle. Let us study some important formulae. Number 1. Intensity of light is always directly proportional to square of amplitude. Number 2. Resultant amplitude square is equal to A1 square plus A2 square plus twice A1 A2 into cos phi, where R is the resultant amplitude of the waves, A1 is the amplitude of first wave, A2 is the amplitude of second wave, and phi is the phase difference between that two waves. From formula number 1, we can calculate the intensity, that is, resultant intensity is equal to A1 square, therefore here is I1, therefore A2 square I2 plus twice into square root of I1 into I2 into cos phi. This is the formula for resultant intensity of the wave. Therefore, let us evaluate it. If I1 is equal to I2 is equal to I0, then resultant intensity becomes IR is equal to I0 plus 2 into square root of I0 into cos phi. Therefore, IR is equal to twice I0 plus 2 into I0 into cos phi. Therefore, IR is equal to twice I0 into bracket 1 plus cos phi, as 1 plus cos phi is equal to 2 cos square of phi by 2. Equation for resultant intensity becomes IR is equal to twice I0 into 2 into cos square of phi. Let us suppose this equation as equation number 1. Therefore, IR is equal to 4 times I0 into cos square of 5I2. If 5I2 is equal to 0, then IR is equal to 4 times I0, that is IR is equal to Imax, that is maximum intensity of light. If 5/2 is equal to 90 degree, then IR is equal to 0, that is resultant intensity is equal to minimum intensity. Therefore, above equation of resultant intensity becomes IR is equal to Imax times cos square of 5/2. This is very important formula for the calculation of resultant intensity. Let us now study the types of intervals. There are two types of interference of light.